Welcome to question number 35 from the January 2016 Geometry Regents exam. This is a pretty lengthy question. It's two proofs that we need to get done, so let's go ahead and get right into it. Now, right off the bat, we know that AW and DE bisect NWD and REA at points W and E. So visually, we know that these two distances are the same length, and we also know that from D to W and W to N are also the same length. Now the strategy I'm going to go for here to prove that the two triangles ANW and DRE are congruent is to use the side theorem. Now the first two sides that we can show are congruent are the lines from A to N and R to D. And we know those are congruent because opposite sides of a parallelogram are always congruent. You'll notice in my statement I also mentioned that the lines from D to N and A to R are also congruent because also they're opposite sides of a parallelogram. Now the next thing I want to try to show is that the line from E to A is the same length as the line from D to W. If we do that, we'll get one step closer to proving that AWDE is a parallelogram, and if we can show that, then the line from A to W and E to D will have to be the same length because we can say that because it's a parallelogram, opposite sides are congruent. Here's how we're going to do it. In my statement, you'll see that I said the line from A to E is half of the length of AR. So this yellow line is half of that in total length. We also know that the length from D to D, D to W or WD, is half of the line from D to N. Because of that, we can conclude that the line from A to E and WD are equal or congruent. Essentially, the line from A to R and D to N are both being cut in half, so each of those half segments are going to be equal to each other because we know A to R and N to D are the same length. Now, we're actually at a really good point where we can actually first prove that the quadrilateral here is a parallelogram because we've now proven that these two sides of this shape are equal in length. All we need to do is state that these two lines from W to D and A to E are parallel and conclude that it's a parallelogram. And we can already say that because we already know that this entire shape is a parallelogram, which means these are parallel lines. So you can see in my statements and reasons, I've added in that AR and DN are parallel because we know that. And we know that because the opposite sides of a parallelogram are, of course, parallel, hence the name. And so we can finally conclude that AWDE is a parallelogram. Awesome, so we've actually now proven this one here. Okay, so now back to proving the two triangles are congruent. I've just redrawn it down here because it was getting a little confusing. Now the two little blue lines, we know those are congruent. The next thing I want to show is that this distance here is equal to this distance here, that they're congruent. And that'll get us one step closer to the final proof. And the method here is actually going to be exactly the same as this one. So I can basically explain that this green line is equal to this green line because they're both half of the distance from here to here, which are both equal. So based on that, hopefully that statement and reason I just wrote in there makes sense. Okay, so now we're at the point where these two green lines are congruent. We know that these two blue lines are congruent. There's one step left. We just have to show that these two lines are congruent. And that's actually really easy to do because we've already proven that this shape in the center is a parallelogram. Therefore, opposite sides of a parallelogram are congruent. And there you go. We have now effectively proven that these two triangles, ANW and DRE, are congruent. And that is based on the side theorem because we have three congruent sides. Okay, and that is it for this problem. That was a pretty lengthy one and a lot involved. So I hope this video was helpful and that all made sense. That's all for this video. Thanks for visiting JD's Regents Preparation.